Lesson 2-4, describe proportional relationships and the constant of proportionality. In this lesson, we're going to learn a new term that relates ratios and rates and proportional relationships, and we call that the constant of proportionality. So our I can statement today says, I can use the constant of proportionality in an equation to represent a proportional relationship. Let's take a look at example 1. The essential question for this lesson says, how can you represent a proportional relationship with an equation? So we're going to be learning about how to take those ratios and those proportional relationships that we've learned about in previous lessons, and now we're going to extend that knowledge to algebra as we learn how to put that in the form of an equation. Example 1. Write an equation to represent a proportional relationship. A sponge is an example of a filter feeder. It takes in food by filtering water through its body. The sponge maintains a constant flow of water through its body. What is an equation that represents the proportional relationship between the time and the amount of water filtered? So take a look at the picture. We can see from the picture that there is water going into the sponge through all those pores. Okay, you probably learned about this in science. And as it goes into the sponge's body, then the water is coming back out at a rate of 8 liters in 10 hours. We also know that a sponge can filter 12 liters of water in 15 hours. So in other words, the sponge is taking in all the water in the ocean and filtering out the food that it needs, and then basically spitting that water back out that it doesn't need to use in order to feed its body. Let's use the information here from the picture and those two rates that we are given and put that information in a table right here in the first part of our work and see if we can figure out a unit rate for how many liters of water that sponge can filter in 1 hour. Here we are introduced to the term constant of proportionality. The constant of proportionality is the constant multiple that relates proportional quantities x and y. It is the value of the ratio y over x, and it is represented by the letter k. So we're going to take the information from the picture and create the table. Hours is our x number, that's the first column. Liters is the y number, that's our middle column. And then our ratio of y to x, or liters and hours, is the third column. So what you'll notice is the first piece of information we were given was the ratio that the sponge can filter 8 liters of water in 10 hours. So we write that ratio as 8 to 10. And what that means is that sponge can filter 8/10 liters in 1 hour. So we made a unit rate out of that. And then do the same thing with the second piece of information where we have 12 liters of water in 15 hours filtered. And that same ratio of 12 to 15 is equal to 8/10 of a liter in 1 hour. So we say the constant of proportionality is 8/10. And we're going to call that and use that letter K to identify it. Now what you might also notice is that the constant of proportionality here actually has another name that we've been using all along, and that name is the unit rate. Now we set up that ratio to find that constant of proportionality by dividing the y number by the x number. And then we can solve that equation. So I'm going to show you what they did kind of over here on the side. They took that k, constant of proportionality, equals y divided by x, And they solved this like an equation where we want the y number by itself. So we would multiply both sides of the equation by x. So what that means is y is equal to the value of x and k multiplied together. Now you might be wondering, well, why is that written slightly differently here? And that's because we often put the y equals on the left side of our equation, and then the variables on the other side usually go in alphabetical order. Now when we need to write the equation that describes that relationship between the time and the amount of water filtered, we are going to use the equation y equals k times x. And we substitute in place of k that 8/10 number, because that's what that constant of proportionality is equal to. And that relates the y number, which is the liters filtered, and that is equal to that 8/10 times the number of hours that the sponge is filtering the water through its body. So the y number is the liters. The k number is that constant multiple that we multiply the number of hours by, which is our x number, and we multiply that by that 8/10. So we can use the equation here, y equals 8/10 times x, to answer other questions about how many liters that sponge could filter in any number of hours that you could think of. Now let's take a look at the Triack question. Maria made 2 batches of fruit punch. The table at the right shows how many quarts of juice she used for each batch. Write an equation that relates the proportional quantities. So you can see in the table she used both apple juice, x. Let me try that again. She used apple juice as the x number and grape juice as the y number. So as she's making her ratio, the ratio is going to be grape juice to apple juice. And this is going to tell us about how many quarts she used of each type of juice to make that fruit punch. So again, we have grape juice as the y number and apple juice as the x number. So our goal is to first find the unit rate. So how many quarts of grape juice is that for each quart of apple juice? Try that on your paper and then restart the video to see if you got that part right. Maria needs to use 1 6/10 quarts of grape juice for each 1 quart of apple juice. So that means our K number, or the unit rate that relates grape juice to apple juice, is 1 6/10. That is our constant of proportionality. The equation that represents that relationship is y equals 1 6/10 times x. Now let's try example 2.